In our digital age, data reigns supreme. It is the lifeblood of our modern society, driving everything from commerce to communication and even our personal lives. From financial transactions to personal information, our lives are increasingly intertwined with vast repositories of digital information. Every click, every swipe, every transaction adds to the growing mountain of data that defines our digital footprint. Traditionally, this data has been stored in centralized systems, often controlled by a single entity. These entities range from large corporations to government bodies, all holding the keys to vast amounts of sensitive information. While convenient, this centralization creates a single point of failure, leaving data vulnerable to a myriad of threats. A breach in one of these systems can have catastrophic consequences, affecting millions of users. Centralized systems are susceptible to hacking. Cybercriminals are constantly evolving their tactics, finding new ways to infiltrate these systems and access valuable data. Malicious actors can exploit vulnerabilities, gaining unauthorized access to sensitive information. This can lead to identity theft, financial loss, and a host of other issues for the affected individuals. Data breaches have become alarmingly common, resulting in the loss of personal data, financial assets, and even national security secrets. The aftermath of such breaches can be devastating, both for individuals and organizations. Furthermore, centralized control opens the door to data manipulation. When a single entity has the power to alter data, the integrity of the information can be compromised. A single entity with access to the system can alter or delete data without detection, eroding trust and accountability. This can lead to misinformation, financial discrepancies, and a breakdown in trust. Whether driven by malicious intent or simple human error, such manipulations can have far-reaching consequences. The ripple effects can impact everything from personal relationships to global economies. The reliance on centralized intermediaries also introduces risks. These intermediaries act as gatekeepers, controlling access to data and often holding significant power over it. When we entrust our data to third parties, we become dependent on their security measures and ethical practices. This dependency can be a double-edged sword, as we are often left in the dark about the true state of their security protocols. History is replete with examples of these intermediaries failing to safeguard data or, worse, abusing their privileged access for personal gain. These incidents serve as stark reminders of the fragility of trust in our digital world. The vulnerabilities inherent in centralized data storage systems highlight the urgent need for a more secure and trustworthy alternative. As technology continues to advance, so too must our methods of protecting the data that fuels it. As we generate and share ever-increasing amounts of data, the stakes have never been higher. The future of our digital world depends on finding solutions that can safeguard our information while maintaining the trust that is so essential to its functioning. Enter blockchain technology, a revolutionary approach to data storage and security. This innovation is transforming the way we think about data integrity and trust. Unlike centralized systems, blockchain distributes data across a network of computers, eliminating the single point of failure that plagues traditional models. This distribution ensures that the system remains robust and operational even if some nodes fail. This decentralized architecture forms the bedrock of blockchain's security and resilience. By spreading data across numerous nodes, blockchain creates a system that is inherently resistant to attacks and failures. Imagine a digital ledger replicated across countless computers worldwide. Each entry is meticulously recorded and verified by the network, ensuring accuracy and consistency. Each computer in this network, known as a node, possesses a complete copy of the ledger. This redundancy means that even if some nodes go offline, the data remains intact and accessible. This distributed nature means that no single entity controls the data or the network. Power is shared among all participants, fostering a more democratic and equitable system. Blockchain operates on the principle of transparency. Every transaction is visible to all participants, creating an open and trustworthy environment. All transactions recorded on the blockchain are visible to every participant in the network. This transparency ensures that everyone can verify the integrity of the data. This open and auditable nature fosters accountability, making it difficult to alter or manipulate data without detection. Any attempt to change a record would be immediately apparent to the entire network. The decentralized nature of blockchain makes it incredibly difficult to compromise. With no central point of control, attackers face a formidable challenge. To alter data on a blockchain, an attacker would need to gain control of a majority of the nodes in the network, a computationally expensive and logistically improbable feat. This high level of security is one of the key reasons why blockchain is gaining widespread adoption across various industries. To understand how blockchain achieves its remarkable security, let's delve into its fundamental structure. As its name suggests, a blockchain is a chain of blocks, with each block containing a set of transactions. Each block is linked to the one before it, creating a chronological and tamper-proof record of all transactions. This linkage is achieved through the use of cryptography, specifically hash functions. A hash function takes an input of any size and produces a unique output of fixed length, known as a hash. This hash acts like a digital fingerprint for the data within the block. Even a minute change to the data would result in a completely different hash. The genius of blockchain lies in linking each block to the hash of the previous block. This creates a tamper-evident chain. If someone tries to alter a block, the hash of that block would change, breaking the chain and alerting the network to the attempted manipulation. Section 4. Decentralized consensus. Guarding against tampering. Adding new blocks to the blockchain is governed by a consensus mechanism. This mechanism is crucial for maintaining the integrity and security of the blockchain. This mechanism ensures that only valid transactions are added to the blockchain and that all participants agree on the order of blocks. It creates a unified version of the truth that all participants can trust. One of the most common consensus mechanisms is proof of work, or POW, used by Bitcoin. POW has been instrumental in securing the Bitcoin network since its inception. In a POW system, nodes, also known as miners, compete to solve complex mathematical problems. These problems are computationally intensive and require significant resources to solve. The first node to solve the problem gets to add the next block to the blockchain and is rewarded for their effort. This reward incentivizes miners to continue securing the network. This process, known as mining, requires significant computational power, making it extremely difficult for any single entity to control the network. The decentralized nature of mining ensures a fair and secure system. The decentralized nature of mining ensures that no single entity can manipulate the blockchain for their benefit. Each miner works independently, contributing to the overall security of the network. The consensus mechanism acts as a safeguard against unauthorized changes. It ensures that all participants adhere to the same rules and that any attempt to alter the blockchain is immediately detected. Any attempt to alter past transactions would require redoing the work for all subsequent blocks, a task that is practically impossible given the distributed nature and computational power of the network. This makes the blockchain an incredibly secure and tamper-resistant system. The global distribution of nodes further enhances security, as it would require a coordinated effort across the world to compromise the network. This decentralized approach is what makes blockchain technology so revolutionary and reliable. In conclusion, the consensus mechanism is the backbone of blockchain security, ensuring that the data remains tamper-proof and trustworthy. It is this robust system that allows blockchain to be used in various applications, from cryptocurrencies to supply chain management. Section 5. Bitcoin, a blockchain pioneer. Bitcoin, the first and most well-known cryptocurrency, provides a tangible example of blockchain technology in action. Bitcoin leverages blockchain to create a decentralized and secure digital currency, free from the control of governments and financial institutions. Each Bitcoin transaction is recorded on the Bitcoin blockchain. This public ledger allows anyone to trace the history of every Bitcoin, ensuring transparency and preventing double spending. The decentralized nature of the Bitcoin blockchain makes it incredibly resilient. No single entity can shut down the network, censor transactions, or manipulate the supply of Bitcoin. This has profound implications for financial freedom and inclusion. Bitcoin's success has demonstrated the viability of blockchain technology in a real-world application. It has paved the way for countless other blockchain projects, exploring applications beyond cryptocurrency.